I think there's a slide missing here, so I'm just going to wing it. We talked about solubility. And concentration is something that's important in terms of a solution. Say you're having some tea and you put some sugar in it. You know, and the classic thing for hot tea is 1 lump or 2. It's like, well, I'd like 4, please. Do you like a lot of sugar, a little sugar? If you have a lot of solute, the solution is said to be concentrated. Concentrated. If there's just a little bit, it's said to be dilute. Those are relative qualitative terms. It depends on context, but dilute is going to have less solute and concentrated has more. So relative qualitative terms are useful, but in chemistry, as you may have guessed, we like to measure things. And so we have quantitative ways of measuring a concentration. So one of those is mass percent. Mass percent is the number of grams of solute per 100 grams of solution. Not solvent, solution. This is different than the solubility, which was grams of solute per 100 grams of water. So this follows the pattern of the part over the whole. The part is the mass of the solute. The whole thing is the whole solution. That's the solute and the solvent, their masses added together. So if we had a solution that's 14% by mass, that means it has 14 grams of solute per 100 grams of solution. Okay, the denominator is solution, not the mass of solvent. I guarantee you there will be a question on the next exam that gives you mass of solute and mass of solvent and asks you to calculate the percent concentration. And the common mistake that a large number of students will make is they'll take the mass of solute and they'll divide by the mass of solvent times 100%, and that will be one of the choices on the multiple choice question. So you've been warned. You have to take the mass of the solute and add it to the mass of the solvent because you want the mass of the whole thing. If we're figuring out the percentage of boys in James's kindergarten class, and there were 5 girls and 15 boys, do we take the 15 boys and divide by 5 girls? 300% boys. Does that make sense? No, that's crazy. You have to divide by the whole number of children. 5 girls plus 15 boys, so it was 75% boys. You can't have a mass percent that is greater than 100%. Because the mass of solute is on the top, the mass of solute is also on the bottom, and there's something else added in here. So if you get a mass percent greater than 100, you did your calculation wrong. Let's do an example. Calculate the mass percent of a sucrose solution containing 11.3 grams of sucrose and 412.1 milliliters of water. Assume the density of water is 1 gram per milliliter. Well, 11.3 grams is the solute. 412.1 milliliters. That's a volume, and we need mass. And they gave us a big hint. Assume the density. So the density is 1 gram per milliliter. So that means it's 412.1 grams of solvent. What's the mass of the solution? It's the sugar plus the water, the solute plus the solvent. So 11.3 grams plus 412.1 grams. Ooh, do I dare do that in my head? 423.4. That's the mass of the solution. what did I do with my calculator? So then the percent, the mass percent, is going to be the 11.3 grams divided by the whole thing times 100%. The grams cancel out. 11.3 divided by 423.4 times 100, 2.67%. Any questions? Mass percent is really useful. It's used a lot in medicine and in biology because it's easy to make up a solution. Chemists don't use it as much because it doesn't relate to numbers of particles, but we still need to know it.